Hello there my friends, hope you all having an awesome day right now. So in the last video we looked at how the quicksort algorithm works, and in this video we shall look at how we can implement this algorithm in Python. So before we get started, I'm going to announce a surprise in this video, and to know what the surprise is, you'll have to watch the video till the end. And yeah, so let's get started now. So first I have the file saved as partition.py, and this is the file where I'll be writing the partitioning algorithm. So def partition, and we are going to pass the array low and high through partition. So array low high. So first we have got to assign the values of I, j and pivot. So I is equal to low, j is equal to high minus 1, because high minus 1 is the index of the last element in the array, and pivot will be the first element, which is array of I. So we have done this part perfectly, and now we need to include our while loop. So while I is less than j. So we are going to be doing all the stuff that we are going to do now only if I is less than j, because there is no point in swapping the elements at I and j when I becomes greater than j or I crosses j. So now we need to specify when I will be incremented and when it needs to stop. So while array of I less than pivot. So when array of I is less than pivot, we need to keep incrementing I. So I plus equal to 1. So when this condition becomes false, then I stops. It stays wherever it is. So then we'll go to j. So while array of j greater than pivot, we need to keep decrementing j. Simple. So it keeps decrementing, and if we find that the element is less than pivot, then we stop j. And when both I and j are stopped, it means that they need to be swapped. So temp is equal to array of I. Array of I is equal to array of j. Array of j is equal to temp. So now we have done the swapping. Note that we are just not going to always swap. We are going to swap only if I is less than j. We saw that in the working video. So if I is less than j, then we are going to be swapping this part. So just like that. So now we have done with this while loop. Now if you recall, after I becomes greater than j, we'll be swapping the pivot with the element at j, because the pivot should go in between the elements which are less than it and the elements which are greater than it. So again we'll be swapping. So here temp is equal to array of j. Array of j is equal to pivot, and pivot is equal to temp. So now we have successfully swapped the pivot element and the element at j. And note that we also need to return j, because we need to know where we have to stop while recursively calling the quicksort function. So that completes the partition function. I've even saved the function right now, and now let's go to write the quicksort function. And before this, I'll just announce what the surprise is. So for the first 10 people commenting pistachios in the comments, I'm giving away free pistachios. So this is the surprise, and now let's proceed to write the quicksort function. So now I have got the quicksort file ready, and we are ready to write the quicksort function. So before that, we'll have to import from the partition function right here this function. So we'll just import it inside the quicksort function. So from partition import partition. So now we have imported the partition function, and we can use it in our program, quicksort function. So we'll write the quicksort function. So def, I'm calling it quick underscore sort, quick sort, and I'm passing array low and high. the same arguments which we passed through the partition function. So what we are going to do in quicksort, we are going to first find the value j from the partition function. So j is equal to partition array low and high. So if you remember, this j is the same one which we returned in the partition function. So we have that j right here. And next, since we have j, we are going to call the quicksort function for the left sublist and the right sublist separately. So quicksort from array, so low will be low and high will be j. And this same function, let me copy paste it. In this case, low will be j plus 1. The reason I'm writing j plus 1 here is because at the position j, we know that the previous pivot element is stored, and we don't want to touch that element right now because it's already sorted. So that's why we are including this plus 1 over here. And in place of high, we are going to pass high. So these statements we are going to execute only as long as there are a significant amount of elements in our list. And if we have only one element, there is no use of partitioning the one element. It doesn't make any sense. So for that, we need to have an if statement here stating that if low not equal to high, because if low is equal to high, then it means that there is only one element in the list and there is no point in swapping. So we'll just quickly put these statements under the if statement. So yeah, now we are done with our quicksort function. Now all that we need to do is we need to give an input list, and let me call this list A. So A is equal to, I'm giving completely random numbers. So 10, 20, 40, 5, 6, 7, 4, 3. So this is my list, and we are going to sort this list. So quick sort, I'm going to pass A for low it's 0 and high is len of A. And in the end, we'll be printing A, since the sorted list is stored in A itself. So let me save the program, let's test it. Okay, so the name quicksort is not defined. So yeah, so the small s is wrong. It should be capital S because I use capital S over here. So yeah, now it should work. Okay, so we have the sorted list over here. 3, 4, 5, 6, 7, 10, 20, 40. So as you can see guys, this list is sorted. The elements are put in their correct order. And so that's how the quicksort algorithm works. And that's it for this video guys. Stay tuned for the next video where we'll be looking at the next sorting algorithm. So bye for now.